my name is Arpita and I'm a developer in this team. So today I'm going to demo on type descriptors for type aliases. So let's start. So type descriptor is basically a metadata about user-defined type. It actually describes how to initialize, copy, destroy, encode, and decode an instance of a type. A type descriptor is automatically generated by default when we have this generate descriptor as true, marked as true. So if the user doesn't want to have a type descriptor for his own complex type or user-defined type, he can simply use this false from the drop-down for generate descriptor. Type descriptors were introduced because sometimes types are too complex for automatic type descriptor to generate. And maybe the automatic type descriptor is also not sufficient enough for our complex models. There can be different textual representation of encoding or decoding functions that the user wants to have in his model. So for that reason, we introduced this type descriptor. The type descriptors are used by target RTist mainly for this particular reasons. Copy the data of an event that is sent, encode the event data into textual representation, and to decode the event data from textual representation. So we have introduced type descriptors for type aliases, which is similar to the type defs as well. So as you see here in the properties page, we have this function bodies written by the user. So we have this copy, decode, destroy, encode, and init function bodies. And once we have the code snippets written for this function bodies, that is how it looks in the Project Explorer as subnodes under the type alias. So let's move to the model and check how it looks. So as you see here, we have one project custom type descriptor, and inside this we have a type alias TLS3, which is of type std string. So in the C++ target RTist, we have the generate descriptor marked as true, and we have the set of function bodies written by the user. So if you mark the generate descriptor as true, it will automatically generate default type descriptors. But as we have written our own function bodies, this will override the code that will be generated by the model compiler now. So let's start building this model and see how the code looks once it's generated. Yeah. So let's go to this type alias function body. Source. Yeah. Body of the C++ generated code. As you see here in the CPP file, we have the function bodies generated for init, copy, decode, encode, and destroy. And the code snippets are the code snippets that we had written inside these function bodies. Similarly, we have introduced this type descriptor hint as well. So the main use of type descriptor hint is when we are using complex types or collection types, for example, list, set, vector, or map. It becomes very difficult to write such big encode or decode function bodies. So to ease out this, we have introduced this type descriptor hint, and we also have a preference set in our Eclipse. So if I go to my tool and see, so Windows, in the preference, we have this real-time development build transformation C++. So once this generate type descriptor for complex type is marked to true, and we apply this, apply and close, and we have one more model using this type descriptor hint. So coming to this model, as you see here, we have a type alias TLS1, which is using this collection type map with the key as integer and the data as character. So if you go to the C++ target RTist, you see we do not have the function bodies written. Rather, we have written some directives like in the type descriptor hint, we have the kind as map, the key type, which is integer, and the data type, which is character. So simply setting the preference and giving some type descriptor hint as directives, it actually indicates or it gives direction to the model compiler to generate the function bodies for this particular type alias of type map. Similarly, you can do this for a list vector as well. So now if I simply build this model and check the code, yeah, build is complete. So let's check the code, navigate to the source code body. As you see here, we did not write any code for the function bodies for copy, decode, encode, and init, but the model compiler has generated the same, and all these complex codes are generated by the model compiler itself. We did not have to write them separately. So this is the advantage of using type descriptor hint. As I have already mentioned, the use of type descriptor is to copy data of event that is sent, or to encode event data into textual representation, or to decode the event data from textual representation. To check this, we have used this model type descriptor hint, where we have passed this data class. So data class has attributes A, B, C, and D, where B and D are using type aliases of map and list, and std map and std list are basically type defs. So if you check how we have passed the data from this capsule, so as you see in the code view, so we have passed a map of integer character from A and B, and from C and D we have passed simply a list of characters. To check whether whether the decode and the encode function works properly, we have passed this data class from capsule A to one more top capsule. So now if I go to this test capsule and check, here we have used this encode and decode functions, and if the encoding and decoding works fine, we have simply printed this log message as pass. One more advantage of using this type descriptors and passing the event data from capsule to capsule is that we can simply also run it as a real-time application instead of using model debugger. So if I run as a real-time application, allow. So as you see here, we get a success message, received event with data, and we have a pass message as well. And the ASCII encoding of the passed data from the data class from a capsule to another is also printed over here. Just to add one more thing, for any help, you can use this also help contents, where we have all the description about the type descriptors and the function bodies and how to use type descriptor hint as well.